So today I'm going to be talking about the 1939 claim made by Carl Pfaffman that cats possess directionally sensitive mechanoreceptors and what modern research has to say about it. Carl Pfaffman was an American-born psychologist who taught at Rockefeller University in New York as well as Brown University. His largest contribution to the field was the research he composed on human taste and smell. However, he published several papers throughout his career on the sensory abilities of mammals and birds and how they experience the world. Mechanoreception is one of the ways in which organisms are able to interpret their environment. A mechanoreceptor is any sensory organ or cell that has the capability of perceiving external stimuli that comes in mechanical form, such as touch. Mechanoreceptors also detect variations in touch, such as changes in pressure, temperature, position, or frequency. Hearing is a form of mechanoreception, as auditory perception is created by sound waves vibrating through a human eardrum. Stimulation of a mechanoreceptor sends an action potential through the peripheral nervous system of an organism and to the central nervous system for integration and processing. It's believed that Carl Pfaffman was the first to make an official claim that cats must possess some type of innate mechanism which grants them superior navigational skills to humans. We've all heard anecdotal stories about cats traveling unbelievable distances to even more unbelievably precise locations, but all but a few of these cases are well documented and reputable. One of the most comprehensive records of long-distance travel in cats occurred in 2013, when a Floridian family cat was left behind at their vacation home when she didn't return from one of her outings in time for the family's scheduled departure. A little over 2 months later, the tortoiseshell cat amazingly appeared in the family's backyard in Florida, a journey that spanned over 200 miles. The microchip in the cat's ear proved that she was the family's cat. Clearly, long-distance journeys without a GPS aren't unheard of in the animal kingdom. The study of how certain species accomplish such feats has been ongoing since ancient times. Some animals navigate using the sun, following it east to west across the sky, while others utilize the sun's polarization for more complex navigational cues. Most familiar to humans is using landmarks as a means of orientation, a method shared by nearly every mammal, whether in their local or migrational habitat. Navigation by olfactory cues is used by spawning salmon and many large herd animals. Birds have been known to navigate using stars, probably due to their brightness. Migratory birds will also choose to fly downwind in the absence of other cues, such as the sun. When those cues are restored, the birds will fly in the right direction, regardless of the wind. Circumstantial evidence indicates that migration routes may be genetically inherited from parent to offspring through DNA, such as in the monarch butterfly. The main theory for a cat's ability to travel long distances is that they're somehow tapping into the Earth's magnetic field. Although humans aren't able to detect it, the Earth is like a giant magnet. Motion from its liquid outer core generates a magnetic field, which is what creates the poles. No one is completely sure how animals are able to detect these fields, but there are two leading theories. The first theory is that these animals possess a mechanical sensor. A protein called cryptochrome has been identified in the eyes of migratory bird species, which theoretically could permit them to visually see the field. The second theory posits that these animals use a chemical sensor. Particles of magnite, which is the most magnetic natural metal on Earth, has been found in many migratory species, which theoretically would allow these animals to feel the sensation of the Earth's magnetic fields. The only animal known to have both of these adaptations is the homing pigeon. Cats haven't been proven to possess cryptochrome in their eyes or magnite in their brains. If the secret to long-distance travel in cats is the ability to detect the Earth's magnetic field, it most likely has to do with the high concentration of iron particles found in their ears, which are one of the main tools they use to sense their immediate environment. The iron could act as a compass, helping the animal orient themselves in a general direction.